Hi everyone, my name is Krishna Akondi. I'm a software developer and co creator of the SAS.js framework. Today I'm going to demonstrate how to build and deploy a React web app using the SAS.js CLI. During my time in the industry, I've witnessed the evolution of JavaScript and web apps, starting from static HTML and CSS web pages to vanilla JavaScript apps to the rise of Node.js and modern front-end frameworks such as Angular and React. Over the years, the workflow for web developers has also changed to reflect this evolution. These days, a typical workflow involves the use of a command line tool to scaffold out projects, create new components, and automate tasks such as builds and deployments. There are opinionated frameworks available such as the Angular CLI and Create React app, which make for much accelerated web development. Another key aspect of the process for modern web devs is a focus on CI CD, DevOps, and automation. So, how does this all play into the SaaS world, and how do we bridge the gap between SaaS and modern web apps? To understand this, let us look at some of the challenges that I faced when I first started building SaaS apps over a year ago. So, the first key challenge was a shift in mindset. So, SaaS devs tend to look at data in terms of tables, so tables in and tables out, whereas a JavaScript dev such as myself tends to look at data as JSON or objects. Another key challenge was the differences between different server types, so SaaS Via and SaaS 9. So, if you were building an app that was meant to work across server types, you'd find yourself writing code to iron out the differences between the servers. Another key thing that I found was that SaaS devs used a browser based IDE like SaaS Studio to write and maintain their SaaS code, whereas I was using a local instance of Visual Studio Code. So, all of these things prompted my colleagues and I to come up with the SAS.js framework. So, what is the SAS.js framework? It's a suite of tools to aid rapid development of apps on SaaS. So it all started with the SAS.js adapter, which is a single JavaScript library which is meant to iron out the differences between SaaS Via and SaaS 9 and provide a uniform API for communication with these servers. It also handles things such as response parsing, authentication, and session management. We also have SAS.js Core, which is our reusable macro library, which can be used in your SaaS projects. And we, of course, have the SAS.js CLI, which is a command line tool that you can use to scaffold out opinionated SaaS projects, build, compile, and deploy them. Let's get started with the SAS.js framework. To start, you can install the SAS.js CLI globally using npm. Since the SAS.js CLI depends on Node.js, it's a prerequisite that you need installed on your machine. So once you have that, you can install the CLI using the npm install command. Once you have the CLI installed, we can scaffold out a React web app using the SAS.js create command. It's worth noting that you can also scaffold out an Angular app, a vanilla JS app, or a SaaS only app using the different options available. So let me bring up my terminal and we can scaffold out a React app. So this creates a folder with the name you've specified and installs all the required dependencies and scaffolds out the project structure in there. So that's now complete. So what that's done is it has created a React app that uses Material UI, and it interfaces with your configured SaaS server to fetch and display data from the demo Springs database. So let's take a look at the project in Visual Studio Code. So the project has a top level SaaS.js folder which has all of your SaaS code and your configuration. So the macros folders where any of your custom macros will live, and services folder will contain your SaaS jobs. So services is a term that we use for a job which has this sort of header block, and in the header block you can specify dependencies such as macro files from the macro library. And there's the SaaS.js config file, which is all important for our CLI. So it contains a number of configuration items. More information about these can be found in the documentation. But for now, let us look at the important part, which is targets. So these targets are essentially an array of different server configurations for our project. So here I've got two targets in here. One of them is called Via and the other one is SaaS9. And the Via is for, of course, Via server type. And the only other important attributes here for now are the server URL and the app lock, which points to the location of your app on the server. So if we dive into the source folder, which has all of the React components, it's pretty much a stock standard React project, uses TypeScript and SCSS. The only thing of particular interest here would be the SaaS context. So this is important as it manages all communication with the SaaS.js adapter, which then interacts with your configured SaaS server. So it provides methods here to log in, log out, and fetch data from the server. So now that we have the app, let us start looking at how to deploy it to our SaaS server. We will first try to deploy it to a Via server. So then step one would be to configure the Via target in the SaaS.js config to point to the right server. So in my case, it will be the Analytium SaaS server with server type SaaS Via, and I want the app to live in the SaaSGF React app folder. Since we're trying to deploy to a Via server, we will need to authenticate first. The deployment mechanism uses the SaaS Via REST API and will hence need a valid access token to authenticate. SaaS.js CLI provides a command for this as well. So you can use the SaaS.js add cred command to authenticate against a specific target. Please note that this requires a valid client ID and a client secret that can be provided by your SaaS administrator. So I'll go back to my VS Code and use the integrated terminal here to run the SaaS.js add cred command. I'm going to give it the target Via. So I'll use a client ID and secret that I've generated earlier. So once I've put in the client ID and secret, it'll ask us to go to this URL authenticate with our username and password, and then put in a code that is returned here. So we now have the code, which I will put in here. So what that's done is authenticated us against the server, and it has created a .env file on your local files system with the access token and refresh token. So it'll use these tokens in all further requests. So once we've authenticated, we're now ready to compile, build, and deploy our app. So what does this mean exactly? So compilation is the process of taking each service in the services folder and recursively fetching all of its dependencies and then combining them into one built file. So if I run the sass.js compile command, we will see exactly what that means. So all of the compile output and build output is typically directed to the sass.js build folder. So if we go into the app init, we will see in there that all of the macros that it depended on have been appended into this build file. Then sass.js build then is the process of combining all of those build files into one file that's ready for deployment. So if we go back and look at our sass.js config, we will notice that there is a build output file name configuration, which is set to my via deploy.sass. And if we look here, that's the output file that's been created. So this is our entire set of services ready to deploy. And if we weren't using sass.js, we could just copy this output and paste it onto SaaS Studio and run it, and it would create all of our services. But fortunately, we do have sass.js, so we can use the sass.js CLI to deploy our code as well. So if I say sass.js deploy -d via, so we can see that it's trying to deploy to the location that we've specified in the config. And looks like we are done. The log from the deployment is also available in the sass.js build folder. So this is the similar kind of log that you would see in SaaS Studio when you execute code. So if I actually go into SaaS Studio, and look at our target folder, we will see that our services have been deployed there. SaaS.gf React app and services has our two services, app init and get data. So at this point, we've deployed all of our SaaS components onto the server, but we haven't deployed our web app as yet. So there's two ways of doing this. The first way is to use rsync to SSH your built app onto the server. So this requires SSH access to the server. I'll quickly demonstrate this now. So if I run npm run build, which is the default build command for the React app, it'll create a built version of the app inside the build folder. So in the package.json, there's a pre-populated deploy script which does the rsync deployment to your chosen SSH account on the given deploy path. So I'm going to populate these variables and run this command right now. So SSH account is my account. Deploy path is a path on the server. So I'll call it SaaS GF React app and then say npm run deploy. So that has rsynced our files over to the Analytium SaaS server. So if I go to my browser and go to saas.analytium.co.uk/me/SaaS/GF React app, I will see the React app loading here. And when the app loads, it already makes a request to the server to pre-populate the drop-down on the demo page. So the drop-down has been populated with areas from the Springs database. So if I click on one and then click submit, make another request to the server and display the fetched data here. So that's the rsync method. But what if you don't have SSH access to the server? We have a way around that. So you can create a streaming version of your web app, which is then deployed using the same mechanism as any of the other SaaS services. So for this, we'll need to configure the stream config for your given target. So if I go back to our config file and then go to the via target, there's a stream config object here. And the stream web property here is set to false. So if I set it to true, it'll convert all of the built web app files into SaaS services. So web source path here is going to be build, which contains the built React app. And then stream service name, I'm going to call it SaaS GF streaming app. So what this is going to do is that when I compile and build my project again, it'll create a set of additional services. So I'll quickly demonstrate this by running compile build again. So now if I navigate to the SaaS.js build folder, there's an additional folder here called webv, and there's a SaaS file with the name of the SaaS streaming service that we've configured here. So what that's essentially done is take our files from the build folder. So there's a bunch of CSS and JavaScript files here. It's created services for those which stream the content in each of those files. And then it's created a main streaming service which streams the index.html file. So now I can run the deploy command again. And now that it has detected the stream web property being set to true, it will also deploy these services. The deployment is now complete, and a streaming version of my web app is available at this URL. So if you notice, it's a SaaS job execution URL, which means it runs a job which then streams back the content of our web app. And therefore, it might be slightly slower than hitting the web app on its own. There we have it. It's a streaming version of the web app we saw a little while ago. And I can still go to the demo tab and make requests as usual. In this presentation, we've learned how to create a React-based SaaS app and how to compile, build, and deploy services using the SaaS.js CLI. We've also learned the different ways of deploying web apps using the CLI. That concludes my presentation. If you are excited by the potential of the SaaS.js framework and would like to contribute or even just try it out, please get in touch. Thank you very much.